Can you guys hear me now? All right, great. Cool. All right. All right, sorry about that, folks, but welcome to the Big Data Meets Machine Learning session. My name is Bruno Faria, and I'm a Senior EMR Solutions Architect at AWS. And in this session, you're going to learn how to architect a Spark environment for data scientists. So before I actually get started, there are some things that I would like to talk about, such as the challenge. Now, I really do thank everyone for coming here, especially because this is one of the later sessions or the last session of the day. And hopefully we're making this exciting and fun enough, and that way no one falls asleep here today. So let's go ahead and get started. And the first thing that I would like to talk about really is the machine learning of assumption versus reality type of thing. This is something that we hear very often when talking to our customers. And one of the first assumptions about machine learning pipelines today is that most of the work is actually spent on the model architecture, or actually with the data scientists configuring and applying their machine learning models or model-specific data processing. That's the assumption. However, this actual assumption is far from the reality. And the reality of things is that where most of the work in a big data pipeline takes is actually during the processing phase. So nowadays, a real-life machine learning application doesn't just require more than predicting with a single model. So for example, your data may need some kind of pre-processing. You may need to do feature engineering, normalization of that data, and you also may need to do things such as dimensionality reduction. So all of these things is done on the data pre-processing or data processing side of things. And this is where we have this assumption versus reality, where we see customers often thinking that most of the work is going to be spent with the data scientist team. However, you need to have good data in order to have a successful machine learning algorithm or machine learning application. And most of you probably already heard about this. So it's not enough just to have the data to back up, but oftentimes that data is going to be raw, is going to be in some kind of format that does not apply for you, does not work with your machine learning algorithm. So there's going to be a lot of pre-processing involved. So this also takes us to another kind of work where nowadays we have sort of, or both of these data engineering and data scientists, they overlap, where oftentimes they need to do similar kind of work in order to have a successful machine learning application. And this is the challenge that we're going to be talking about today, and how can you overcome these challenges and have this kind of workflow where you have big data as well as being applied with your machine learning. So part of the agenda today, the first thing that I'm going to be talking about is a little bit about Spark, Apache Spark. Then I'm going to move on to talk about Amazon EMR and SageMaker. And then I'll show you how all of these services can be integrated together to create a machine learning workflow or a pipeline. And then lastly, I'll be showing this, finishing this off with a demo. So I do have a demo that's about 15 minutes long, where I'll be putting everything into action and showing you everything that I've talked about today. So I know a lot of times you might be talking over here all day, but if you don't see a demo or something in action, it might not be real. So in this case, I'm going to be showing that everything that I am talking about is real, and it is something that customers are using in production today. So the demo is going to be at the end of this. So let's go ahead and get started. And the first thing that I would like to talk about is Spark. So Apache Spark is an open source distributed framework for data processing. So in other words, you can use Spark in order to make your application parallel or distributed in order to process massive amount of data. Now Spark also has in-memory computing abilities. But not only that, it is also optimized for high performance. Now, when I say high performance, just to give an idea of how performant Spark really is, a typical Spark application can be up to 100 times faster than a Hadoop MapReduce application. So this kind of really shows you where Spark high performance comes from. And also, Spark is not only used for a single use case. There are various use cases that Spark can be applied with. For example, you can use Spark for batch data processing, as well as streaming data for use cases where you have to do near real-time computations. And Spark also offers machine learning libraries, as well as graph databases and a SQL interface. Now, the best thing about Spark is that it also has native APIs for Java, Scala, Python, SQL, and R. So chances are that a lot of data scientists, or most data scientists, they're familiar with one of these languages. So that means that a data scientist can easily pick up on Spark and start developing a Spark application right away. It's very easy to use. Not only that, but the Spark API is very concise. And that means that oftentimes you can reduce the amount of lines on your machine learning application, or even reduce the complexity of that application. And there is one particular component of Spark that I would like to focus on for the next couple of sessions, and that's going to be the Spark data frames. Now, the data frames, they are a distributed collection of data organized into named columns. So what do I mean by this is that you can think of a data frame as the equivalent of a table within a database. It has your schema, it has your columns, as well as your rows. And also, a data frame can be constructed from various different sources, including external databases. You can also use structure files and even existing RDDs. Now, RDDs stands for Resilient Distributed Dataset, and that's also another component of Spark that I'm not going to talk too much about it today, but just know that RDDs is one of the lower levels API of Spark, is what Spark had available when initially was developed. But nowadays, most of the work with Spark is actually done using the data frame API instead of RDDs. But just know that you can still construct data frames from an RDD. Also, a data frame supports various different file formats that includes text, CSV, JSON, ORC, Avro, Parquet, many more. And to give an example, during the demo, I do have an example where I'm loading data from Lib SVM format. And that's a format that's really, it's optimized for machine learning, certain machine learning algorithms. And this is also another format that's natively supported by Spark. Now let's talk about another component of Spark, which this is one of the core components of this session today. And that's Spark's ML Lib, or machine learning library. And ML Lib is Spark's machine learning library on top of the data frame API. Now, there was Spark does support ML Lib with RDD. However, the Spark documentation stated that it's currently in maintenance mode, so they're not adding any new features to it. And on top of that, the Spark documentation also mentions that starting with Spark 3, it looks like they plan on deprecating RDD altogether. So this is yet another reason why I'm focusing primarily on using data frames here today. So with the ML Lib, or Spark's machine learning library, you also have the ML Pipelines API, which is an API that allows you to create an entire machine learning workflow from a single application. So during the workflow, you can include stages that would transform your data, convert your data to some kind of different format, or add columns to it. And you can also use that for performance tuning evaluation. So there's various things and useful features that you can do with the ML pipeline API, which I'll talk about some of them here as we go along. On top of that, with the ML Lib, you also have the ability to do model selection, as well as tuning your application, your machine learning application with hyperparameter tuning. You can also do cross-validation and train split validation for this. So let's talk still on the components of ML Lib. Another thing about it is that it provides various different algorithms. So with Spark ML Lib, you can use algorithms including for classification, regression, clustering, as well as collaborative filtering. Now, one of the useful features for ML Lib is also gives you the ability to do featurization. So if you need to do something such as feature extraction or transformation or dimensionality reduction, these are all very common tasks for a data scientist. It is possible to do that all using the ML Lib or Spark's machine learning library. And one of the particular components that I'm talking about now is also the ML pipelines. And the ML pipelines provides you with a set of tools to construct and evaluate that entire workflow. Now, an ML pipeline in Spark consists of stages. Now, a stage can be a transformer stage, and this is a stage that's actually going to transform that data into the data frame into a new data frame. So, for example, you could do some kind of feature extraction or feature engineering in order to create a data frame containing a column with new features or containing a prediction column. And the other stage, whenever using ML Lib, is also the estimator stage. And this is the stage where you're going to actually apply your model and it's the algorithm that trains on the data. And you have the fit method to perform this. So when you execute the method, you're in essence pretty much training on that data set. So let's talk about an example Spark application. So to make this a little bit more clear, here's an example application of a Spark ML code. And this is directly from, with some minor changes, but this is directly from the Spark documentation. Now this is an entire machine learning application written in Scala, and this is for Spark. So this is native Spark. It's not integrating with SageMaker yet. That example will be shown later. But let's cover what each of these means in a little bit more detail so you can have a better understanding of how Spark ML Lib or Spark ML pipelines work. So in the very first line, we have over here our training variable, and this is where we're loading our training data set. In this case, we're loading from a Parquet file format, and we're just simply creating a data frame for this. This is what's going to be using as our training data set. And next, we configure the ML pipeline by specifying the stages for the pipeline. And here we have a pipeline consisting of 3 stages. The first one is a tokenizer stage, and that stage is pretty much going to take a text line and is going to tokenize that into an array or a list of words instead of being a single line. That's what the tokenizer stage is doing, and here's where we specify input and output columns. The next thing about that, we have our hashing stage, and this is pretty much a hashing function that we can also specify the amount of features for this data. And if you notice, one of the things about this is that the input column for our second stage is actually the output column of the previous stages. So this kind of gives you an idea of how all of the stages within an ML pipeline, they're linked together, they're chained together in order to form this workflow for your machine learning. And then we have our estimator stage here, which is our logistic regression stage. We're using logistic regression to apply the model over our data. So here we specify some parameters for this particular algorithm, and then we just create the pipeline by specifying those 3 stages. Now, once we want to fit the pipeline into training documents, we just specify that we execute the fit method and specifying the training data. And this is going to create our model. And once we have that model, we can actually test predictions by applying that model into our testing data. And this is what the last 2 lines in essence does. We'll load our test data, and then we'll run a transformation to where we're doing predictions and applying that model over the test data to verify how efficient that algorithm or that model really is. So moving forward, that was it for Spark. I would like to talk a little bit about Amazon EMR, which is stands for Elastic MapReduce. And EMR is our managed service for running Hadoop ecosystem applications in AWS. And the applications that EMR includes, it includes Presto, Spark, Hadoop, Hive, and many other applications. So EMR is up to over 20 different applications available for you to launch and run those applications. But not only that, but with EMR, you can also process massive amounts of data from various different sources, including S3, DynamoDB, Redshift, Kafka, and many others. Now, one other thing about EMR is that it provides various features for you to run this kind of job in very low cost. For example, with EMR, we have the concept of transient clusters. And with transient clusters, by default on EMR, you're going to keep your storage in S3. And if you're keeping your storage in S3, you can have this concept of transient clusters, which is when you launch a cluster, that cluster will run for the duration of a particular job. And once that job completes, the cluster will terminate itself. And at that point, you're saving costs because you don't have to keep a cluster running at all times. And since your data is in S3, you no longer have to worry about any sort of data loss. EMR also has an auto-scaling feature, so you can configure the cluster to auto-scale based on particular load events that happen in the cluster. And also EMR provides you with the ability to run spot instances directly on that cluster. So all of these are features that will allow you to run your Spark application in very low costs. So this is the reason why I'm using EMR today to run our Spark cluster. So part of the demo I'll be launching an EMR cluster, and that's what we'll be using for Spark. And the next feature of EMR is that it's secure. It's integrated with all the AWS services for security, including IAM, as well as the AWS KMS. And with the simple click of a button on EMR, you can also configure the cluster to encrypt your data at rest as well as data in transit. So you can configure your Spark workload as well as build your machine learning pipeline in a very secure way. So having said this about EMR, let's talk about the next service that will be part of our application here today, which is Amazon SageMaker. Now, what is SageMaker? SageMaker is a fully managed service for machine learning. Now, this is a pretty broad statement, so I know a lot of you are wondering, well, what do you mean by managed machine learning service? So let me quickly cover some of the features and main components of SageMaker. Which one, SageMaker provides you with pre-built notebooks, or you can also use SageMaker notebooks, and these are Jupyter notebooks, in order for you to do data exploration, visualization, and so on. SageMaker also comes with built-in machine learning algorithms. These are cloud scale algorithms, and in essence, these are infinitely scalable algorithms. These are very efficient algorithms that SageMaker comes with built-in to it. And also with the click of a button or a simple API call, you can configure SageMaker to execute a training job. So if you want to train over a data set, you can simply do a click of a button and SageMaker will create what we call a training job to train that data. SageMaker is also optimized, so you can use SageMaker to train and tune your machine learning pipeline. And also, the other thing that it has is one-click deployment for you to host that machine learning model directly on SageMaker. So once you have created your model, you can simply click of a button or run an API call, and that's what we'll be doing from Spark. And the end result is that you have your model hosted on SageMaker, and then you can simply make API calls to make predictions using that particular model that you have hosted. And all of this is fully managed, so SageMaker is taking care of auto-scaling your cluster for your training jobs or for your endpoints. SageMaker is going to handle things such as security checks, as well as handle node failures and various other things. So you can almost look at SageMaker as a one-stop shop for all your machine learning type of tasks that you're doing today. So now let's talk a little bit about the SageMaker Spark SDK. And this is really what's the core of this talk or this session here today, is how can we integrate Spark and SDK, SageMaker and Spark together. So the SageMaker Spark SDK, it is an open source SDK available directly on GitHub, and it's actually pre-installed on EMR 5.11 and above. So now that doesn't mean that you can only use the SageMaker Spark SDK from EMR. You can, if you're running your own Spark distribution, you can still use it. It just means that you have to install it and configure accordingly to your application. So again, this is also another example of why I chose EMR to do this today, is because EMR already has all these things built in, and it's easier to just run with it. Also, the SageMaker Spark SDK provides APIs for both Scala and Python. And it gives you the ability to train, import, and predict with Amazon SageMaker all directly from your Spark application. So, and you can configure your application to do all of these things, and at no point in time you have to configure Spark to launch another application or to trigger some kind of different workflow. And this is where we have, this is the great thing about all this, is that you get to do this entire pipeline all within your Spark application and have this entire integration seamlessly to users. And the other component that the Spark SageMaker SDK provides is data frames in and data frames out. In other words, the SageMaker Spark SDK is built to work with data frames, and it's going to automatically serialize and deserialize your data to and from the protobuf format. So let's talk a little bit about the benefits of Spark with SageMaker. So that's a question that comes up often. So as you heard me talking about earlier, Spark is great at doing machine learning things, and so is SageMaker. So the question that does come up is, why can't I just use SageMaker, or why can't I just use Spark? Well, the first benefit of integrating Spark with SageMaker is that you have the ability to decouple ETL and machine learning. So take, for example, your ETL workload may be completely different, may require a completely set of different hardware than your machine learning workload. For example, maybe for your ETL workload, you would like to run R4 instance types, while for your training job, you like to use P3 or some kind of a GPU instance. Now, you can certainly run a Spark cluster and GPU instance, but that's not going to be ideal, and it can be also something that's very costly. Therefore, whenever you're scaling these independently of one another, you have the ability to really configure each type of workload separately. And this also avoids you from having to size your Spark cluster in order to run your training job. Again, if you're decoupling them, you no longer have to be worrying about if you're going to be running your Spark application directly from a GPU instance. And you also have the ability to avoid the time-consuming if you need to scale your EMR cluster, you no longer have to be thinking about how long it's going to take to scale, and you can just let SageMaker handle that particular workload for you. And also, you run your ETL once, and then you can run various models in parallel. Now, the second benefit that you have with the integration of SageMaker and Spark is also the ability to run machine learning algorithm in any language. So the Spark machine learning library is great. However, you might need something else. In fact, you might need to run some kind of ML algorithm that's not available directly on Spark. And if you are using Spark with SageMaker, you have the ability to use a different algorithm. And you also have the ability to use deep learning frameworks such as MXNet or TensorFlow. Both of these frameworks, they're also natively available both on SageMaker as well as EMR. So again, you have the ability to use these frameworks if you like to do so. And you can also write your own custom code in any language. So you're not just tied into Spark's native API that's supported. You can use your custom application in any code you like. Now, this is a particular interesting benefit that we have, is that you get the best prediction performance. So what I mean by this is whenever you have the ability to perform your machine learning predictions without using Spark. So again, Spark, where it really shines is whenever you're doing ETL and you're processing massive amount of data. However, oftentimes you might have some kind of latency requirements in order to process the data in, if you want to improve the latency for running a small batch predictions, that's not going to be possible if you're using Spark because of the overhead of the Spark framework, which again is really useful for doing ETL. So it would be difficult if you're trying to do, let's say, a prediction for a single image or a single record. You would be almost, not to say pointless, however, you would be just an overkill for you to run a small prediction for a small batch using Spark. And you can also achieve real-time predictions by using SageMaker models that are hosted in SageMaker without using Spark. And lastly, you also get to optimize your own prediction instance. So whenever you're hosting that model in SageMaker, you also specify the particular instance that you like to use for your endpoints and all these things. So this goes back to the point where I mentioned earlier of decoupling your ETL from your machine learning. Now that's it for some of the benefits. Now let's talk about some of the common use cases that we see customers using Spark along with SageMaker. And the first use case is, of course, for data preparation as well as feature engineering before training. So if you recall back to one of the first slides that I showed you, which was the machine learning assumption versus reality. And with this, you have now the ability of using Spark to prepare your data or do feature engineering and use Spark in order to achieve that part of the pipeline. And this also ties in with using Spark to do data transformation, as well as using Spark for batch prediction. So as I mentioned before, the SageMaker Spark SDK supports data frames, and you can use those data frames in order to apply your predictions to, let's say, a large amount of data. You might have terabytes or petabytes of data somewhere, and if you like to apply a prediction to all of that data, then that would be a really good case where you're using Spark along with SageMaker in order to perform this large batch prediction. And of course, this ties in with the data enrichment and predictions. And also the last use case that we see doing often is to deploy Spark machine learning models at any scale. So in other words, you can create your Spark, your model using Spark machine learning, and then you can simply host that model on SageMaker afterwards, and that model can be at any scale. So let's talk a little bit about developing an Amazon SageMaker application. An Amazon SageMaker, Spark SageMaker application. So there are various ways to do that. For example, you can download the Spark SageMaker SDK, and you can use your IDE of choice and then create your own application. However, for the demo purposes that I'll be showing you today, I would like to create a Spark, SageMaker Spark application in an interactive way. So for this, I'm going to be using notebooks, in this case, SageMaker notebooks with Jupyter. And from that Jupyter notebook, we're going to run our Spark application, or that Spark machine learning pipeline that's integrated with SageMaker. Now, one thing to know about this is that whenever you need to run Spark from a notebook like Jupyter, the way that Jupyter will communicate with Spark is through an application called Lib. And Apache Lib is ultimately, it's a REST server for Spark. So that allows you to make REST API calls to Spark. But not only that, but that's the actual application that notebooks like Jupyter, Hue, as well as Zeppelin will use in order for you to create, excuse me, in order for you to create Spark notebooks. And now the other good thing about EMR is that Lib is one of the application choices that you can have installed on EMR. So whenever you launch the EMR cluster, you simply also select Spark and Lib, and at that point, you have a cluster that's fully ready to be your processing backend for your machine learning application. So this really takes us to now the portion that I think a lot of you might be interested, which is seeing the demo for this. So I do have a demo that I pre-recorded in advance. Now the reason why I pre-recorded this demo is it was because it does take a few minutes for you to launch an EMR cluster, as well as a few minutes for you to run your training job. So therefore we would be losing some minutes here. Therefore I decided to pre-record the demo. However, as we go along, I'll be explaining everything here as I'm doing with the demo. So let's go ahead and get started on this demo. Now the first part of this demo, as you can see, here I am on the AWS Management Console. And the first step is to actually launch an EMR cluster. So from the AWS console, I can simply go to the EMR console, and from there I'm going to create our Spark cluster for our application. So here we just go to create cluster. And the first step when you're creating an EMR cluster is to select the different applications that you like to have installed. So in this case, as I mentioned before, we need to use both Spark as well as Lib in order for us to communicate with Spark from Jupyter Notebook. So once we select the applications, the second step is to actually specify the VPC and subnet, as well as the instance type that you like to use from that, for that particular cluster. So this ties in back to our example where you want to make sure that you have different hardware for your specific workloads. So in this case, for our Spark cluster, this is going to be our processing cluster, ETL cluster. We're going to be using M4.large instance. So I have one master node and two core nodes for this particular cluster. And then on the third step, these are just general settings for EMR, which includes the cluster name as well as logging location. So not much over here tie into our demo. But the next important part is going to be the security of this cluster. So that's going to be on our next step over here. And let's go ahead and just move over to the next step. And let me move too fast. So here it is. This is the actual security step of whenever you're launching an EMR cluster. So the important thing to know over here is that for the security options, I did select an EC2 key pair, and this is an SSH key. And simply it's something that would allow me to SSH to the cluster if I like to. Now the reason why I'm selecting an SSH key here is because I will be logging into the cluster and to show you an example of what the logs will look like whenever you're running your application. However, for a lot of workloads, many customers, they will just launch EMR clusters to run their jobs without even using an SSH key. So if you have a use case where you don't even need to log into that cluster at all, you can simply launch the cluster as is without an SSH key. Now, the other important part on this particular step is the EC2 instance profile that EMR is using. So in this case, I have a EC2 role called EMR EC2 default role. Now, the one thing that this role does need to have in order for it to communicate with SageMaker is that this role needs to have a policy that allows it to make API calls to SageMaker. Because in essence, whenever you're using the SageMaker Spark SDK, what Spark is going to be doing is going to be making API calls to SageMaker. Therefore, you need to allow the EC2 cluster role to make those API calls to SageMaker. Now, the other thing that I would like to show you over here that's important is going to be the security groups. Now, the security groups, I get to select the security groups for our cluster here, the master node, as well as the core and task node security groups. And the important thing to note here is that in order for Jupyter to communicate with Spark, your security group does need to allow communication to the Lib server. I don't remember the port number off the top of my head, but I will be showing the port number here in a second on how the configuration is done. But the main takeaway here is that your security group for your EMR cluster does need to have allow connectivity from your Jupyter notebook in order to access Lib. So I'm going to go ahead and this is next. I just create the cluster. And once the cluster is being created, it's going to be in a starting state. And once the cluster is fully done being created, it's going to go into a waiting state. And that means that the cluster is ready to run a job. So while the cluster is creating, the next step is going to be to launch a SageMaker notebook instance. And this is going to be Jupyter that we'll be using to develop our Spark application. So here I am at the AWS Management Console at the SageMaker part of it thing. And here I go to the SageMaker notebook instance and create a notebook instance. Now you simply give your notebook instance a name. And one of the things that you should know over here is the notebook instance type. So in this case, I'm just using a small instance, a T2 medium, and that's completely okay because remember, our Spark cluster or EMR, Spark on EMR is really what's going to be doing the processing or the heavy lifting for our application. So in general, your Jupyter, your notebook instance doesn't need to be that powerful or have that much resources because that's where Spark is going to come in. And then we also have our particular instance that we'll be using for our training job as well as endpoints. So again, for the notebooks, we can have a small instance type to use for that. Now, the other thing that you should know over here while you're creating a notebook is going to be the permissions for the notebook or the networking portion of it. And the network is where I specify the subnet as well as the security group for my SageMaker notebook. Now, if you recall earlier, I mentioned to you that you need to have connectivity to EMR, to the security groups. Therefore, for this particular demo, I'm using the same security group and subnet as EMR. And this, by default, I have a rule configuring there that allows that SageMaker notebook security group, it allows it to connect to the EMR master node. Now, one other cool feature over here is the GitHub repositories for SageMaker notebooks. So in this case, I already created some notebooks in advance, and I would like SageMaker to clone that repository automatically when I'm launching the notebook. So here I can specify the URL for my GitHub repository, and by doing that, SageMaker will automatically clone the repository already with my notebooks automatically once it's launched. So after this, I can specify tags, and that's optional. And the next step is just to create that notebook instance. Now, once the notebook instance has been created, it just takes a couple minutes for it to be ready. So it's first in pending status, but once it's ready, it's going to go into in-service status. And now we can actually click on Open Jupyter. And this is actually going to open up our Jupyter notebook where we'll develop our application from. So let's go ahead and do that. So let me go ahead and open up the Jupyter notebook. And now over here, you can see that I already have some notebooks automatically when I open up this Jupyter console. And this is because of, if you remember earlier, I had specified a GitHub repository containing my notebooks. So this is already in place because of that. Now, before I can actually use Spark from Jupyter, there's one thing that I need to do first, which is configure sparkmagic and specify where is my Spark cluster, the location of my EMR cluster that will be used. So in order to do that, I can simply pull up the terminal directly from Jupyter, and I just need to, I downloaded the example sparkmagic configuration file. Now, sparkmagic is a Python library that allows the Jupyter notebooks to communicate with Lib or Spark. And here I'm downloading the simple sparkmagic config.json file. And there's only a couple of property changes that I need to do, which is you'll see here in a second. So here I'm downloading the example config. Let me go ahead and fast forward this. And once the sparkmagic config.json is downloaded, I'm going to edit that file and specify my EMR cluster URL or my Spark cluster URL. So in this case, when we open up the sparkmagic configuration, we can see the different configurations for the Python kernel, PySpark, as well as R, Scala, and so on. Now, if you notice over there, it's pointed for the URL, it's pointed to localhost and port 8998. And 8998 is the Lib server port number, and that's the port number that needs to be open within your security group. So here, the only thing we need to do is replace the localhost with the actual URL of the EMR cluster. So to get the EMR cluster URL, I can go back to the AWS Management Console, and here we can see that the EMR cluster is now ready to go. It's in waiting state. And here we have the master public DNS, and that's the DNS that we want to replace localhost with. So in essence, what you're telling right now, Jupyter, is that use this EMR cluster to run your Spark applications. So let's go ahead and do the replacement, and then we save the file. And that's it. That's all it is for sparkmagic configuration. And now we're ready to actually pull up a Spark kernel and run our Spark application. So in this case, I already have an example notebook that's using the Spark kernel, and this will be the notebook that I'm mentioning here before. Now, as we can see over here, it's using sparkmagic, the Spark kernel. And the problem that I'm doing with this application, the problem that I'm trying to solve, just to give you an idea, this is a multi-class classification for Spark problem. So I'm using the XGBoost algorithm in order to classify the MNIST data set. And that's a data set of images containing handwritten digits from 0 through 9. So what this application is doing is trying to predict what is the number that's been written on that image. So if you have an image with the number 1 written on it, this application should predict that that's the number that's written on that particular image. So this is the problem that I'm demonstrating with this particular application. So the first thing that I'm doing over here, I'm going to specify my training as well as test data set. And if you remember earlier, I'm using the lib SVM format. So I'm simply using spark.read.format, and I'm doing lib SVM. I'm specifying the number of features. So in this case, this data set contains 784 features. That's because the images, there are 28 by 28 pixel images. So 28 times 28, 784. And that's the amount of features that we have for this particular image. So once we have our data set that's loaded, our training as well as our test data set, it's time to actually create and invoke the model. However, as you can see, before I get to that, the first thing that happens when I actually run this first paragraph, it says starting a Spark application. So now this is me. I've gone back to the EMR cluster, and I've SSH directly to the master node. And here what I want to show you is what the Lib server log looks like whenever you're running the Spark application. So here it's starting up the application. We can see over here that it's using Lib as a default application. And once the application is actually ready to run, we can see over here that you're going to be returning an application ID as well as the state. And you can see that it says Spark session available. So that means that our Spark application is good to go, and we can go ahead and get started on actually creating the model and invoking the model. So before I actually execute this particular paragraph, just to give an idea of what this some of the lines of code here means. So this is where I have that core integration between SageMaker and Spark. So this is a Spark application that's actually using a couple of stages for our ML pipeline. So here we're using the XGBoost estimator, and this is the stage where we're actually doing the training on the data. Now, if you notice, the difference between this and the previous example Spark application that I had shown you guys is that for this, I'm actually offsetting everything for the training job over to SageMaker. So here I specify the instance type for SageMaker to use for this training job, as well as the instance count for that cluster, the initial instance count type, as well as an IAM row. So the takeaway here is that SageMaker is going to be running this training job. And then we're going to actually use we're going to do a transformation here to where we're going to predict the first 5 rows on our training data set. So this is really what that application is doing. And then I'm executing a show just to show that data frame, the schema of the data frame, and to make sure whether or not our predictions are correct for the test data. So let me go ahead and go through this part over here. So whenever we initiate this application, here is what you're going to see from the Spark cluster or from the Livy logs. You're going to see that it's starting the application. And the one thing that you should notice is that you're going to see that it's now making API calls to SageMaker. So here we see that it's using the XGBoost estimator, SageMaker estimator, and it's actually making a creating training job request for this. And here we have all the configurations for this training job, including the job name, as well as the input data, output data location. Now, one of the things to note is that now we see that the training job is in progress. This is what's being reported directly from the Spark application. Now we can also see this directly from the SageMaker console. So if we go back to SageMaker, we can go directly to training jobs and see that the training jobs that our Spark application has created. In this case, it has created one that's currently in progress, and this is what's executing the training portion of our Spark application. So here we can see that it's starting the application, it's still in progress, and from the SageMaker console you also see information such as the training image is the XGBoost. So all the information you can find directly here. So let's go ahead and fast forward a little bit. And once that training job actually gets completed, the next step for that Spark is going to do is going to be to actually create an endpoint for our job. So it's going to create a model, and then it's going to create an endpoint in order to host that model that we have just created. So here where it's making a create endpoint request. So it is making an endpoint to create an endpoint in SageMaker, and this is where our this machine learning model will be hosted at. So same thing as before, we can go directly to the SageMaker console and look at the endpoint that's being created. So this is the endpoint that's being created by Spark, and that's the endpoint that later on we can use to make API calls and use that in order to make predictions on our data. So let me go ahead and skip this to once the endpoint creation is completed. So here, now once this is completed, now we're actually running the transformation of the data. So this is the part where I'm running on the application the actual transformation in order to predict the first 5 rows of that. So here we can see that it's starting the job to show where I have that directly on my Jupyter application. And here in a bit, that application is going to be complete. So let's go ahead and see what does that look like once it's completed. So here, after I executed this particular paragraph, this is the output of that SageMaker application. And the interesting thing to note over here, this is our label and predictions for the data frame. And here we can see that the label, these are the numbers that actually are with those images. So we can see that the first image has number 7 in there. And our predictions for it, based on the features for this particular image, was actually 7. In fact, we can see that the XGBoost algorithm is really good for this kind of problem because every single one of our predictions, it was actually correct. And it matches, well, at least the first 5 rows, it matches correctly based on our labels. So here we have number 4, and based on the features for number 4, it predicted that it is indeed number 4. So now, what if you want to simply use an existing SageMaker endpoint and make an API call to that without having to start over by creating a new endpoint or do everything that we did earlier. That's also possible. So you can simply already leverage this existing endpoint, even from your Spark application, to do your batch prediction. So here, the next example, I'm showing you how you can make a batch prediction using an existing SageMaker endpoint. So I'm also using the same XGBoost algorithm as I have used before. Now, one of the things about the XGBoost algorithm is it does need to have the input format as CSV or libsvm. But here the thing to know is that I'm specifying do not create an endpoint policy, meaning use the existing endpoint that I have in there. And this time around, I'm actually running a prediction on a data frame containing 10 rows. So let's see what is the results that I got returned by running this prediction on 10 rows. And let's see if we also get that right. So here I specify the training data, and I specify transformation on that to predict the first 10 rows. And we can also see that every single one of our predictions was actually correct. So number 9, number 5, and so on. So this really shows that this algorithm is working well. So at this point, you can move forward and pretty much having that model hosted on SageMaker. Now, the next question would be, all right, this is how we did it from Spark. And now we have that model on SageMaker. It's being available for us whenever we want to make predictions. So what if you want to make a prediction on a single record? So as I mentioned before, you can still make your predictions without having to use Spark. And that's what the next example is. So here I'm running a test in our prediction by just using a single record for our image. And I'm making this prediction without using Spark. So here I'm using an example libsvm format dataset. And if we're looking at our training sample, this is what the libsvm format looks like for that image. So this is a single row, and it contains the label as well as the different features for that. So let's go ahead and run this. And once we run this prediction, and this is using Python, we should be able to determine what is the prediction for that number, which is label number 5. If we look at our record here again, let's see here. So we can see that our label is number 5. So this, the prediction for here should be number 5 as well. And let's see if that matches. And here it is, label is number 5, and our prediction is also number 5. Now, one of the cool things for you to note here is that this prediction took 178 milliseconds. That's because it was the first time that I executed. If you ran it again, it's actually going to be even faster. So this would be the example where if you're trying to run your application without using Spark, and you can do these inference or predictions for single records based on this. So this concludes the demo for everything that I wanted to show you. So let me go ahead, if you can go back to the slides really quick just to finalize. Let's see here. So I just had a couple of other slides, but there you go. So we got done with the demo, but that concludes for the demo. And the main takeaway that I would like for you guys to take today is for you to look over our documentation. So the Spark, our SageMaker documentation as well as the Spark documentation have various notebooks. So all of the examples that I showed here today is available online. So you can go in there and start using some example notebooks in order to test Spark integration with SageMaker. And really that concludes here for the session today. And once again, I appreciate all of you for coming and staying all throughout the session despite being late. And I hope you really got something useful here that you can take back with you and use it for your daily use cases. So once again, thank you for coming. And please don't forget to complete the survey at the end of the session. Thank you, everyone.